My name is Bob D'Amico from Vitrek. I'm the Eastern Regional Sales Manager, and today we're going to be talking a little bit about power analyzers in general, and then we're going to talk a little bit about specifically about Vitrek power analyzers. Okay, like I mentioned, Chad seemed to be having a little technical difficulties. Chad's our VP of Sales. Email address is right there if you have any questions or need to contact us at any point in time. And like I mentioned, my name is Bob D'Amico, the Eastern Regional Sales Manager over at Vitrek, and there's my email address as well. Okay, first thing I want to do is I want to lay a few ground rules down. Everyone is going to be muted, or if you haven't been muted, please mute your microphone so we can, and if you do have a question, the best way to utilize that is to utilize the little chat bubble. We have someone monitoring. Brian, I believe, is Brian Withers from our engineering group is monitoring the chat, so he will answer the question via chat if possible. If not, we have a couple of breaks in our presentation where we do have time for questions and answers and so on. So with that, we'll get going a little bit. Okay, a little bit about the company Vitrek. Vitrek's been an industry leader in high voltage test and measurement for over 30 years. We're headquartered in Poway, California, which is a suburb, or may not even be a suburb. It's right outside of San Diego proper. All our products are designed and built in San Diego. We serve over 30 countries, and our main product lines are high pot and electrical safety testers, cable test systems, power analyzers, which are the products we'll be talking about today, high voltage meters, and our new electronic DC loads, and we are an official ISO 17025 accredited calibration lab.
Bob, this is Chad. I was able to call in on the phone. Can you guys hear me now?
Okay, yeah, we got you. Go ahead, Chad, take over.
Yeah, I don't really understand. I was sitting there talking to myself, and everything on my end looked same as it was prior to 10 o'clock. So once again, you guys, sorry about the technical difficulties. This is Chad Clark with Vitrek. We just wanted to talk about some of the industries that we serve. It's a very broad industry, when it comes to compliance testing and measurement. Everything from sub-assemblies to finished goods, aerospace, medical, motor, photovoltaics, cable and harness assemblies. It's a very broad sense of applications that you can apply our products to. And with that broad product line and product application space becomes a very broad customer base. We work with anyone from appliance manufacturers to military and aerospace. We're getting more and more into sustainable energy. It really started with photovoltaic testing. Now we're more into wind, efficient lighting, things like that. And we also support, the test houses of the world, the ULs and TUVs and things like that, where they're actually doing some type testing on products and validation. So we have 4 main product categories. I'm kind of broken up here on the screen. So kind of what we're known for initially since 1991 has been the full function, all-in-one automatic high pot tester. Where you're able to set limits, test to those, everything can be interfaced to a computer. Still a big part of our business. We have a couple different product lines that feature that. It's the 95X platform and the V7X. And then, as you know, power analyzers. I have a few different power analyzers in the PA900 series that we're going to get more into later. We do offer a full feature DC load. It's a 150 to 500 watt version up to 500 volts. And then obviously we have the 4700 high volt meter, which really stands on its own. It's kind of a replacement or an alternative to a high voltage kind of system where you're using a resistive capacitive divider with a meter. So that kind of makes up the majority of our product line. So throughout the presentation, we're going to have a couple of spots where you guys can ask questions. If you want to ask a question or you have a detailed technical question, it might be best just to throw that in the chat. You can see on the right side of your screen, there is the chat function there. Go ahead and type that in, and we might be able to, or hopefully we'll be able to get that responded to you via chat or privately if we don't think it applies to everyone here. Otherwise, wait for this question section to pop up. Go ahead and unmute yourself and let your voice be heard. So I guess at this point, I'm going to hand it back over to Bob, and he's going to take it from here. Thank you very much.
All right, thanks, Chad. Thanks again, everyone for attending our PA 900 Series Power Analyzer webinar, and we're going to get started. Okay, we're going to talk a little bit about power analyzers and where they're used. For the most part, if a company is either developing a brand new product or they want to enhance a product that they have, one of the more important issues there is the power source that's powering this device, whatever it may be, a toaster, aircraft, whatever it may be. During that process, it's very important to be able to test for efficiency on that power source. Typically, you're running, you're connecting a power analyzer to maybe an input on a power source, the output on the power source, and performing an efficiency study. That would apply to either the product is new or if it's a product enhancement. Another area where power analyzers are used, and Chad touched on this real briefly, is the test labs. The nationally recognized test labs, which include folks like UL, CSA, TUV, and CE. They currently do use many of our different types of products in their testing labs, and like Chad mentioned, these labs are there to make sure that products are safe for the general public, and using a power analyzer certainly is part of one of the tests that they do perform. To a little bit lesser degree, power analyzers can be used also on a production line. There's always been that saying that size matters, and the Vitrek power analyzers have a very small footprint, very lightweight. Typically you think about pulling a power analyzer out to test the end of a line on end of a line production for a particular product, and you sit there and you say, oh my goodness, this is a very big unit. I don't know if I really want to do this, but using a Vitrek power analyzer enables you to more easily implement a power analyzer in your production scheme. Okay, we're going to talk a little bit about some of the very specific functions that a power analyzer does and tie that into very specific application or market segments. Probably the most important function a power analyzer can provide to you is efficiency studies. I've listed a couple of different energy segments: alternative energy, which includes wind, photovoltaic or solar, hydroelectric, and nuclear as far as energy sources. And I've put a little picture up over there. And in most of the cases, as are the case with many of the other applications that are listed here, efficiency, you've got a power source, you need input, output, and you want to be able to take that and maximize that efficiency to get to the highest efficiency level, to drive down your costs in electric usage, and so on and so forth. Motors and drives, same type of situation. In the case of a motor, a lot of times people want to check the efficiency of the motor by having mechanical type of parameters and elements on the output side: rotation, torque, slippage, so on and so forth. They want to tie that into the input power that's going into the motor. Hence, again, output over input, you're getting your efficiency studies. Power conversion and power supplies, kind of the same thing, but power conversion is really what it's all about. Being able to test efficiency for whatever that power source is going to be. Transformers, same type of thing. You've got a situation where you've got a transformer that's taking a signal, doing something to it, stepping it up, stepping it down, whatever it may be, and then outputting that signal. So you want to make sure that transformer is operating as efficiently as possible. Lighting, especially in the lighting industry now with these LED drivers, same type of thing. Is your power source, taking the output power over the input power, making sure you're absolutely maximizing your power conversion source. Electric vehicles, kind of interesting. Electric vehicles are kind of a catch-all for all the applications as far as power conversion and power supplies. You can see in the little picture I've put up on the screen. There's DC to DC converters. There's some kind of power electronics converters, onboard charging. All these types of different applications all kind of fit in electric vehicles. Next, to a little lesser degree, power monitoring. It's used again in a lot of the same types of applications as the efficiency. Monitoring is more along the lines of, once the product has already been developed, it's ready to go, you may want to, do a testing on it for a little while. So what you hook up your power analyzer, and now you got it running, you've got your product running, and you're just making sure that it's actually meeting all the specifications, mainly for efficiency, making sure the unit is operating as it's supposed to. Okay, similar to the monitoring is consumption. Consumption, I separated it out a little bit because it takes the monitoring to another level where you may be wanting to do like an integrated power measurement where you're turning on a function of a power analyzer and having it monitor what's going on with the device under test. But in this case, you're actually monitoring the voltage, the current, the watt hours, how much power is this thing really using over a specified period of time. So that's kind of where consumption comes into the mix. To a lesser degree, power analyzers can also be used as a power quality device, although there are power quality analyzers out there in the market. But because of one particular feature of the Vitrek power analyzers, which is our history function, and I'll go into that a little bit later on in the presentation, you can actually hook our power analyzer up to utilities, a UPS type system, to do a long-term recording to find out again how that power is being consumed, monitored, or whatever. In the case of a UPS, UPSs typically just sit idle until you have a power issue. So what you may want to do is once the power has gone out and the UPS kicks in, having that power quality monitoring capability on the Vitrek power analyzer would allow you to monitor the UPS, make sure everything is working as specified. Okay, next we're going to talk a little bit about compliance testing, and I've got two slides here, and I broke them down in a very certain way, and I'll explain to you why I did it that way. Like Chad mentioned, Vitrek started out as being a compliance house, with the high-pot testers and so on. We've carried that over into our power analyzers to some degree, and there are a couple of testing standards out there: EN 60034 for motors, RTCA-DO for avionics, and IES LM79-19. The motor testing spec calls out for efficiency tests for motors, standard methods for determining losses and efficiency from these tests. It includes efficiency and also harmonics. The RTCA is an avionics test procedure that talks about environmental conditions and test procedures for airborne equipment. And the lighting industry, the IES, the Illuminating Engineering Society, has just updated a document that they've had for quite a few years, which talks about the optical and electrical measurements of solid state lighting, mainly LED and OLED products. Now, the reason why I call out these these three in particular is Vitrek power analyzers in our manuals will actually tell you how to perform to these three different types of standards. Okay, so for example, on the lighting application, it'll come out there and say, do an efficiency study, set the unit up this way, and you'll be kind of in the ballpark of where you got to be. Whoops. Okay, the second compliance testing slide, and the reason why I separated it out is there are two standards that are actually built in to the Vitrek Power Analyzer series. And what I mean by built in is we not only have a way to tell you to perform the procedure, we actually have what the standards are, the actual data that goes along with it. And we have that for EN 50564, which is a spec for standby power. A lot of measurements that are done on a lot of electronic devices, to make sure that they're Energy Star compliant. Standby tests are when you've got a unit that's not powered up, but it's still drawing some power. The standby power test can be run on a Vitrek power analyzer and get you your test results. Log your data, and however you want to do it. You'll notice in the lower left-hand side of my screen, I've got a device in there that Vitrek makes called our LTA-1. That basically eases the connection of a device that plugs into a standard wall outlet. You could take your device, plug it into the LPA1, hook the LPA1 color-coded cords up to the back of the PA900 series power analyzer, and easily perform your standby power test. Okay, the other built-in standard is the EN 61000-3-2, -3-12, and -4-7, which talks completely about harmonics emissions. You'll notice the bottom left screen, which is an actual screenshot off of our unit, again, is enabling you to assess a piece of equipment under test and run that test for the specified period of time. But this, similar to the standby power, is actually giving you what are acceptable levels for harmonics. The screen just to the right of that is part of the setup screen on our power analyzer, where it actually lists all the different classes that apply to that EN 61000 spec for different types of equipment and the acceptable harmonics levels. The screen in the upper right is an actual view from our harmonics screen that shows your harmonics. What you'll notice on there is, if you could see, there are little red tick marks, kind of little horizontal lines, and those are the limits associated with, in this case, let me get my mouse going here, Class B, which happens to be portable tools, arc welders, getting the appropriate level of harmonics to be tested. Okay, we're going to move on to another topic more specific to the power analyzers that Vitrek has. But before I go there, does anyone have any questions at this point in time? So you can unmute yourself if you want to verbally ask the question, or use your chat bubble, and we can do it that way.
Hey, Bob, I don't have any questions per se right now. I just wanted to do an audio check.
Oh, okay. All right, I got you loud.
You can hear me now, and I'm using my computer. Okay.
Yeah, we got it back.
All right.
All right.
Okay.
So if there are no questions, I'll start moving on. And again, if you do have a question, please mute your microphone, but definitely use the chat bubble, and we can get you set up with that. Okay. All right, now I'm going to get into the specifics of the PA900 series power analyzers and some very kind of important features. First item is our modularity and our scalability to design a power analyzer to fit your needs. I'm going to kind of put that towards the end of our features here, because I do want to talk about the actual the cards that go into the unit, which actually talk more to the modularity and the scalability of our power analyzers. All of our PA900 series power analyzers come with a 7-inch high resolution LCD touchscreen. Excuse me. We've got our standard set of interfaces. If you look at the back panel in the lower right, you can see this section right over here that I'm going over with my mouse. Standard interfaces that come with the power analyzers are Ethernet, USB, and RS-232. And you notice that all three of those interfaces are in that nice tight slot on the back panel. If for some reason GPIB option is needed, what you can do is you can purchase that option, and you could actually remove the cover of the unit, remove those two screws, and that those three interfaces kind of pop out. GPIB interface takes its place. Okay, one of the other nice features of our PA900 series are, again, we talked about the built-in compliance testing for standby power and harmonics, which are the built-in functions that actually have the data stored on the device, as well as the motor drives, avionics, and so on for compliance testing. The PA900 series power analyzers can also be daisy chained. Multiple units, that number's kind of, it's a high number, which you probably will never need to use that many power analyzers. But what that does for you, as you can see on the back panel, again, we have 4 slots for 4 different channels of inputs for voltage and current. You can actually daisy chain these and have multiple units, which would get you 8, 12, 16 channels of power analysis capability, and they can all be tied in to be synchronously measured. So if you have something on channel 12, you want to compare it to channel 1, let's say, you can easily do that. Tied in with that, being able to daisy chain and so on, we have a real nice feature built into our power analyzers called a virtual power analyzer, or VPA. There are up to 3 VPAs per PA900 chassis. Each one of those VPAs can be configured from 1 to 4 channels. So what I'm going to do to explain that a little bit better, that really helps with our efficiency groupings and our efficiency calculations. So for example, I could take just the 3-phase motor. I want to take the input of that, and I'm going to say I'm going to apply phase 1 to channel 1, phase 2 to channel 2, phase 3 to channel 3, and I'm going to assign that to VPA number 1, for example. So now when I go ahead and look at my front panel, I can set it up to say, hey, I don't want to look at just the individual channels. I want to look at them collectively as a VPA. So I call up VPA 1, and now I'm seeing the sum of all 3 of those phases and the appropriate power measurements. Okay, another nice feature is we have an oscilloscope that is capable of monitoring up to 6 traces. Very high speed, 384 megasamples per second. Our scope harmonic screen can also double up as a spectrum analyzer. We have the built-in data logging capabilities with recording intervals from 10 milliseconds up to 100 hours, and you can record up to 16 parameters on that data logger screen. Units also capable of measuring up to the 500th harmonic, even at 400 hertz, which is our avionics frequencies. We have a history screen, which allows you, which is really that long-term recording capability that I mentioned when you're doing, for example, maybe a power quality study for, a week or 2 weeks or something along those lines. Our history screen allows you to be able to look at up to 4 parameters from all of our recorded data. So any 1 to 4 up can be displayed at a period of time. And there's nearly infinite recording capability with PA900s, with zoom capability up to 1/64th of the total span. Now, the next topic is the input cards. I'm going to kind of push that down a little bit because I want to show you a wiring diagram first, an example of how you would wire the unit up. Then I'm going to get into the specific models, the input cards, and that will really bring out the beauty of the scalability that I was talking about. Okay, I have an example here of a solar panel and how to hook it up to our power analyzer. Notice over on the left side, I've actually got a solar panel module or a string of cells that may be available. Typically, those are outputting a DC voltage. And what I'm doing in this particular case, I'm going to set up virtual power analyzers to be able to monitor the efficiency of the boost converter and the DC-AC converter, which is kind of blocked together in the middle of the diagram there. So I'm going to take my DC voltage and current and apply them to channel 4. And I'm going to assign channel 4 to my VPA number 1. Then what I'm going to do is the output of my DC to AC converter is outputting a 3-phase voltage. So what I'm going to do is take my voltage from channel A and hook that up to channel 1, voltage and current. I'm going to take my voltage and current from my B phase, hook that up to my channel 2, and take my voltage and current from my C phase and hook that up to channel 3. Now I'm going to assign VPA number 2 to channels 1, 2, and 3. So now go turn around the front panel, go ahead and do my efficiency calculations. I say I'm going to take my measurement results from VPA number 1, which was my channel 4, which is my DC. I'm going to put that in my denominator. And then I'm going to take my VPA number 2, which is my 3-phase voltage and current from channels 1, 2, and 3, and put that on top of my equation. Now I've got my VPA number 2 divided by my VPA number 1, and there's my efficiency. Go over to my front panel, and I'm going to go over some of the screenshots, and I'll show you where you can actually display your efficiency. So that's just to give you a quick idea of how easy and quick it is to be able to set up a in this particular case, a solar panel type situation where you've got some power conversion going on and you can measure your efficiency accordingly. All right, now I'm going to start talking about the units and the scalability and the modularity that I was mentioning before. All the previous slides lead to this next portion, and it's really, you can make our power analyzers whatever you want them to be. You can make them as accurate as you want, as little accurate as you want, as many channels as you want, and that's what I'm going to go over right now. So for our PA900 series power analyzer, there are 4 different types of cards that can be inputted into the back of our unit. If you take a nice close look at the picture of the back panel, you'll notice right under where it says channel 1, you see a little AD on there. That happens to be the AD card. Now our A card is our most accurate card, providing 0.045% of reading with 24-bit resolution and a 1 megahertz bandwidth. There are 3 different current options for all of our cards, except for the motor card. The A card, the 3 different current options. The D option, which is where the AD is coming from, is a dual shunt, which allows for very low levels of current readings. Let me just see something here. Here we go. For example, on a D card, on its lowest range, it's an auto ranging card, but on its lowest range, it can measure currents as low as 0.1 microamp. So you get some really nice, for standby power, things along those lines. You'll be able to get some real nice readings. The H option for our current inputs is our high current option, whereas our D card, having dual shunt capability, can monitor up to 20 amps max. Our H card is, for the most part, it does not include, it's just a single shunt, but the H stands for higher current capability, bumping that up to 30 amps. And the X option for current is our external current probe option, where you can use if you have a need to monitor more than 30 amps, you can hook up an external current probe, scale the unit accordingly, and now you're reading up to 500 amps, 1,000 amps, whatever current capability the specific probe has. The S card also has those same 3 current input options. The S card, a little less expensive route to go, gives you 0.15% of reading, 22-bit resolution, also 1 megahertz bandwidth. The W card, again, same accuracy, same current options, 22-bit resolution, and that has a 5 megahertz bandwidth. That's what the W stands for wider bandwidth. And the last option as far as input cards is our M card, which is our motor transducer channel card. So if you're doing an example where you want to check the motor's efficiency. You want to have some mechanical data input into the back of the power analyzer that will give you items like RPM, slip, torque, things along those lines. So from there you can do your motor monitoring for resolution. Now the next step up in our PA900 series is our PA910. And what we did here is if you look, there's only 2 cards available for this unit. So what we tried to do is we have the same accuracy, 0.045% of reading at 24-bit resolution and 2 megahertz. So we bumped up the bandwidth a little bit for that 0.045% accuracy category, excuse me. And we have our 1 card, our V card, which is also has 2 options as far as current goes. So that T option is going to get you the ability to go from 0 up to 30 amps. Remember the other card, the A card, went from 0 to 20, and with the high option, the high current option will take you up to 30. Here you're going from 0 to 30 from the get-go. The X is also the external current probe option, and the PA910 also has the M card capability for our motor transducer. Okay, now the last of the 3 power analyzers and our top of the line unit is our PA920, which is one of our newer units. And what we did with this one is we added a little bit more capability with the input cards, but most importantly, our U card is our most accurate at 0.024% of reading. Now, again, all these accuracies are all power accuracy readings, okay? 24-bit resolution, 2 megahertz bandwidth. That 0.024 is probably one of the leading accuracy cards, enabling our power analyzer to be one of the most accurate on the market today. We added a B card, which is 0.045% of reading, 24-bit resolution, 5 megahertz. So that's equivalent to that W card that we saw for the PA900. And then we have a K card, which is 0.045% of basic accuracy, 24-bit, 2 megahertz resolution. The big thing with the K card, the K stands for kilovolt. It has a 3.3 kilovolt maximum measurable voltage, and you can also get a motor card for a PA920 also. One point of interest I wanted to make: all of the accuracy readings here are monitored at 0.024, 0.045% of reading. Now, the one thing that's real nice about that is, and one thing that sets us apart from our competition when it comes to power accuracy readings is, with our unit, you're going to get that power accuracy reading, whether it's 0.024, 0.045, over the whole range. What happens with a lot of our all of our competition is, as you change over from one range to another, the accuracy spikes up. So you're not getting flat accuracy readings across that whole current range that you think you may be getting. So really, really important feature. And I wanted to go over the cards real quick with you guys just to let you know you have a lot of flexibility here, whether it's the channel cards, the accuracy. Another point I wanted to make is, if for example, you decide, hey, I want to buy one of these and I only need 1 channel right now. Okay, so you buy your unit, you have an AD card in there, let's say, then maybe 6 months from now, you say, yeah, I really want to add another card or another 2, 3 cards into my configuration. What you can do is you can contact us, purchase the new cards. We will actually send you the card with calibration data, and you could put the cards in yourself. There's about 4 screws on the side of the case of the PA900, and you notice there's a couple of screws on the back panel. You undo all those screws. You could pop your cards in yourself and change your configuration. Pretty much, a few minutes it'll take you to put the cards in. So just wanted to bring that point up. Okay, at this point, that kind of almost finishes up my my presentation, but I did want to take a quick break here to see if anyone had any questions. So you can unmute your mic if you want to do a verbal question, or if you want to just do chat, you go ahead and do that as well. Okay, if no questions, I'm going to move on to the next slide.
Bob, I'm not seeing anything in the chat.
Okay. Should I move on, or we got a question in there in the gallery?
I think you can move on.
Okay.
If
Like I said,
anyone does have a
yeah,
specific question, obviously you guys can shoot in an email at any time, and we can get that question answered for you.
Okay, the next couple of slides, I'm just going to go over some of the screens that we have available for being able to look at the data. The first screen is our power data screen. The parameters that are available are voltage, current, power, parent power, reactive power, power factor, and frequency. And then if you look in the upper left-hand portion of this screen, it says VPA1. That will allow me to actually take a look and see efficiency measurements. So I could go ahead and click on where it says VPA1. That will give me a drop down in efficiency. If I have my VPA set up properly, I'll be able to get my efficiency readings out of this as well. So that's the eighth parameter that can be viewed on this particular screen. You notice also that there's a lot of extra detail. So I have both AC and DC readings on here as well. That's my detailed screen. Okay, our harmonic screen actually is very nice, very easy to use. Like I mentioned earlier, we have the ability to measure from harmonic number 1 up to 500 if need be. We're getting both a dual display, both graphical and tabular or numerical on the left side. And if you want to be able to look at, let's say, harmonic number 200, if you take a look at the harmonic screen in its lower left-hand corner, to that little yellow tab, you can actually touch that with your finger, slide it over to harmonic 200, and now your display over here will give you 7 or 8 different values in that range from 200 to 207, let's say. Okay, you can look at all voltage, current, or power harmonics. You can have limits turned on, like I mentioned with some of those harmonic specs, those IEC specs. It would actually put those red tick marks on your graph here if you decide to turn your limits on. You can have either a linear or logarithmic display of either values or percentages. And spectrum analyzer can be shown in place of harmonics, which is real nice. So instead of seeing your harmonics with numbers, number 1, number 2, number 3, and so on, and their values, you can actually have the frequencies listed down below and your values on the left side. So kind of nice. Okay, we have a vector screen that can show up to 10 different vectors. We can display voltage, current, and phase all at the same time. And if you have multiple VPAs, you can get, like for example, a 3-phase motor. You can get the voltages between phases and actually see those vectors as well: A to B, B to C, and C to A. Okay. History screen is that feature I had mentioned early on, as far as like if you want to do like a quick power quality thing, where you need to be able to run your unit for a long period of time. With the Vitrek PA900 series, our history screen, as soon as you have that unit turned on and hooked up, it's actually logging data from as soon as you turn the unit on. You can always stop it, restart it, and so on. You have the ability on the history screen to record up to four functions from a list of, it's actually more than 7. I forgot to make that change, so I apologize for that. But you can look it up to 4 pieces of data from all the data that's being recorded. Our display capabilities can be looked at, a lot of days. I mean, because it's almost an infinite recording cycle, you can record data for quite a long period of time, and you do have that 1/64th zoom capability. I think this is one of the last screens I'm going to show you real quick is our oscilloscope screen. You can see it's called scope right here. I have 2 different views where we have a multi-trace and a multi-cycle screen, or you can decide to look at 1 cycle view at a time. You can look at up to 6 parameters at one point in time. You can scale them, offset them, change the color, change the time base, trigger points, and the accuracy is actually very good, as high as 0.03%. Okay, last point I want to make is we had mentioned early on that we are an official ISO 17025 accredited lab. All of our equipment is NIST traceable. You get a NIST traceable certificate with all of our equipment. If you need to have data with that, we can provide that for you at an additional charge. We also provide 17025 calibration for an additional charge. We're accredited by the A2LA calibration lab certification. And I think that's the last slide. Any additional questions or questions that we may not have been able to pick up from before?
Hey, I just wanted to read the reminder that Susie went out. I want everyone to know that we'll be recording this presentation. We're going to send it out, and we'll also send you, I believe, a PDF of this presentation.
Yeah,
I want to thank Bob for doing a great job helping put this together and present it.
Yeah, and remember, guys, if you have any questions after the fact, please email us, contact us at info@vitrek.com. We'll get your questions answered, whether that's technical questions, pricing issues, whatever you may have. Okay, and that's the end of my presentation. I want to thank everyone for giving us a little bit of your time and your busy day to participate in this. And like Chad mentioned, you'll each get a PDF copy of the presentation, and actual recording will be residing on our website as well. So again, thanks much. And Chad, if you have anything else to say.
That's pretty much it, you guys. I apologize for the technical difficulties I was experiencing. I was just sitting there talking to myself and figured you could hear me. We'll get this out, and I look forward to talking to you guys in the future. I appreciate it.
Okay, guys. Thanks again, and have a great day.
Thanks, guys. Talk to you soon.
Okay.
Bye.